That moment when you open a new dataset and freeze? Too many columns, too many numbers, no idea where to begin. Every data analyst has been there. And in this video, we'll share a systematic approach that you can use to tackle any dataset with confidence. Using real human resources or HR data from engaged metrics, you'll learn exactly how to start making sense of all those numbers. By the end of this video, you'll be able to perform initial data exploration and understand what's in your dataset. You'll generate and interpret descriptive statistics. You'll identify patterns in your data and detect and analyze outliers. Let's start where every data analysis begins, importing our tools and loading the data. Next, we load our dataset using Pandas' readCSV function and examine its contents. Let's take a moment to observe what we see in this output. The head method is crucial for initial data inspection as it shows us sample data without overwhelming us with the entire dataset. The info method is particularly valuable because it shows us three critical things: the count of the total rows and columns, telling us the size of our dataset, the data type of each column, object for text, float 64 for decimals, etc., which affects how we can process them, and the number of non-null values in each column, immediately highlighting where we have missing data to handle. Now that we understand our data's structure, let's clean and analyze our numerical columns. First, the salary column needs preparation. Let's break down what each line of code does. First, we access the salary column and use the string method, replace, to remove $signs. Next, we convert these clean values to numerical floating point data with as-type float. Then we handle missing values by replacing them with the mean value using fill-in-a. Finally, we verify our changes by printing the first few values with head. Here, the describe method automatically calculates 8 key statistics for each numerical column. Count shows how many non-missing values exist. Mean calculates the average value. STD measures the standard deviation, showing data variability. Min shows the minimum value. 25% represents the first quartile, where 25% of values fall below. 50% represents the median, or the middle value. 75% represents the third quartile, where 75% of values fall below, and max shows the maximum value. By selecting only the numerical columns first, with DF column names, we get statistics relevant to quantitative analysis. But numbers aren't our only concern. Let's look at our categorical variables using value counts to see the distribution. The value counts method counts how many times each unique value appears in a column, which is perfect for understanding categorical distributions. Here we can see the size of each department. We notice an issue. Department names aren't standardized with inconsistent capitalization. Let's fix this. The str.capitalize method is applied to each string value in the department column, making the first letter uppercase and the rest lowercase. This data cleaning step ensures consistent naming for more accurate grouping and analysis. Now comes the exciting part: discovering patterns in our data using groupby operations. This powerful code combines several methods. Groupby department splits our data into separate groups based on department name. Ag lets us apply different aggregation functions to different columns. We request the mean and count of satisfaction scores to see both average satisfaction and response rates. For salary, we calculate only the mean to compare compensation across departments. Finally, round 2 makes our output cleaner by limiting to 2 decimal places. The result is a multi-level data frame showing these statistics for each department, allowing us to spot patterns between satisfaction and compensation. This code shows several important techniques. First, we use str.capitalize to standardize the capitalization of work mode values. Next, str.replace helps us standardize specific text by changing remote work to just remote. Then we use a combination of groupby and describe to get comprehensive statistics for each work mode. Unlike our previous aggregation, describe automatically provides count, mean, standard deviation, min, percentiles, and max. This gives us a richer view, not just of averages, but the full distribution of satisfaction scores across different work arrangements. Next, let's take a look at our outliers. Outliers can either be data errors or interesting insights. Let's create a custom function to identify them systematically. Let's analyze this function line by line. We first define a function with parameters to make our outlier detection reusable across different columns. We use the quantile method to find Q1, or 25th percentile, and Q3, 75th percentile. The interquartile range, or IQR, calculation subtracts Q1 from Q3, showing us the range where the middle 50% of values lie. We establish bounds using the standard statistical formula, 1.5 times IQR, below Q1 and above Q3. The Boolean expression creates a filter for values outside these bounds. We apply this filter to the data frame to return only the rows containing outliers. This approach is more robust than simple standard deviation methods because it's less sensitive to extreme values. Here, we apply our function and examine the results. We call identify outliers with our data frame and the salary column name. The function returns a filtered data frame containing only the outlier rows. We use len to count these outliers and print the total. For more detail, we can select specific columns with the df column names syntax. The head method shows us the first few outliers rather than all of them. When we find outliers, don't just identify them, investigate them. Are they errors in the data collection or entry? Do they represent special cases like executives or part-time workers? Or should they be excluded from our analysis and handled specially? This systematic approach to outlier detection is essential for accurate data analysis. In this tutorial, we covered fundamental data exploration techniques, loading and inspecting data structure with info and head, cleaning and standardizing data with string methods and type conversion, calculating statistics with describe and custom aggregations, exploring patterns with groupby, and detecting outliers with IQR calculations. Each Python method we used serves a specific purpose in the data science workflow, from Pandas read CSV for data loading to advanced techniques like multi-column aggregations. Understanding not just what these methods do, but why, and when to use them is key to effective data analysis.